So on to some key examples for the hypothesis test. So you'll remember in the last video we talked about what a hypothesis test does. Here is a typical exam question. This one's from edXL. And we'll talk through it and make sure that we can use that structure that we had, those four different things that we needed in our response to make sure that we hit all of our marks. So Brad has planted 25 seeds in a greenhouse. You're going to have to get over the contexts. They're normally quite stupid, but you know, we deal with it. We're doing the maths. He's read in a gardening book that the probability of one of these seeds germinating is 0.25. 10 of Brad's seeds germinate. He claims, here's the claim that we're going to refute or confirm, that the gardening book has underestimated the probability. So we're testing at a 5% significance Brad's claim. And we need to state our hypothesis clearly, right? Well, that is step one, decide on our hypothesis. So we'll define a random variable x. X is a seed germinating. And we know that we are following a binomial germinating, you get the point. So we know that x is following a binomial. We've got 25 seeds in our sample with a probability currently of 0.25. Okay, our hypothesis then. Well, our null hypothesis is that the probability remains at 0.25. Our alternative hypothesis, well, let's have a think about what the question has asked us. So H1, is the probability bigger than 0.25, less than 0.25, or just not 0.25? He's claiming, Brad this is, that the gardening book has underestimated the probability. So he is claiming that the probability is actually greater than 0.25. And we're testing at a 5% significance. So we've set up our hypothesis. We know what our significance is. Now we need to think about our sample. So we are looking at what is the probability of getting our 10 seeds germinating, but we'd like to do more than that because the probability of just getting 10 is very small. It excludes every other possibility. So I want to look at 10 or more. Quick little trick with these is to have a look at which way your probability is working. So if your probability is a greater than probability that we're trying to potentially accept, we should be looking at greater than or equal to whatever the value is. So this is 1 minus the probability that x is less than or equal to 9, which is 0.0713. Now that is greater than 0.05. So there's a 7% chance that this would happen anyway, that the gardening book was right, and actually 10 seeds could germinate 7% of the time. And we said it was significant only if it was under 5%. So we are going to have to, there's our statistic done, we're going to have to reject, what are we rejecting? Well, we're not significant, so we're rejecting H1. And we now have to conclude in the context of the statement, in the context of the question rather. So there is not sufficient evidence to suggest that the book has underestimated. I'm actually going to write it out because it's so important. So suggest that the book has underestimated. So notice the language here. We're talking about sufficient evidence. It's of course completely probable that it has underestimated, but we're talking about, is there enough evidence to suggest that it has? And we have decided that because we're testing at 5%, 7%, that's not enough evidence. So there's our 4 parts. So first part, we set up our hypothesis. We wrote down our significance, and this is important. This doesn't feel important at the moment, but we're going to look at a two-tailed test in a second, and that's where it becomes really important. We tested our sample for whatever it was that we were doing, and then we made a conclusion in the context of the question. So a teacher thinks that 20% of the pupils in a school read the Dino comic, chooses 20 pupils at random, so there's our sample, and finds that 9 of them read Dino. So first things we've got to do here is give 2 reasons why a binomial distribution might be suitable, and we have to do these in the context of the question. So they might be things, well, we know there's 4 reasons why we might use a binomial distribution. We just need to write them in the context of a question. So they are that there are 2 distinct outcomes. Well, we've got that, haven't we? We can say students read Dino or they don't. So that's our 2 outcomes. There's no other option. It's a completely sort of binary experience like that. And that the probability in each case can be considered independent. So our events are independent. Now, obviously, we know in the real world that if one student reads it, probably that's influencing other students, but we can assume for this model that that's the case. And we've got a constant probability, and we have a fixed number of trials. So I'm going to pick a fixed number of trials. So we're selecting 20 students. That's our fixed trials. But any of those in the context of the question would be absolutely fine. Okay, it says then test at the 5% significance level whether or not there is evidence that the percentage of pupils that read Dino is different from 20%. So not up, not down, different. And we now need to state our hypothesis. Okay, so let's define our variable for a start. So x is defined as pupil reading Dino. And we are saying that this random variable follows a binomial. We've got n as 20 and our probability as 20%, which is 0.2. In which case our null hypothesis, H0, is that the probability remains at 0.2. Our alternative hypothesis is not that the probability increases, not that the probability decreases, but that it is different from 0.2. So that means I need to consider each extreme. I have to think about what we call a two-tailed test. Oh, tailed. Because I'm looking at it being different from 0.2, it's not like it's increasing, in which case our sort of small bit of probability is all the way up the top, or that it's decreasing, in which case our little bit of probability is all the way down at the bottom. We're different, so we have to kind of equally split our probability. So our 5% probability becomes 2.5% at each tail. So I'm actually testing at a 2.5% significance either side. Okay, I'm going to pick the sort of larger, larger? Yeah, like increase tail, just to consider it. So when I look for my probability, S, probability that x is, and we're dealing with 9, I'm going to look at greater than or equal to, and I'm going to want to be testing it against 0.025. So that probability there, that's 1 minus the probability that x is less than or equal to 8. Using your calculator, I am trying to find my question. That's 0.00982, so on and so forth. Well, that number, 0.00982, is less than 0.025. So now I can make my conclusion. I'm going to accept H1. So I'm going to accept my null hypothesis. There is evidence to suggest that well, what does the question say? Evidence to suggest that the percentage of pupils reading Dino is different from 20%. Percentage of pupils reading Dino is not 20%. And I'd probably write that in language if I had more space. So that's it. So we've seen a one-tailed test and a two-tailed test in this video. Check out the next video for finding the critical region.